Okay, it is Monday, February 15th, and we are starting broadcasts, although no one actually knows that yet. Let's see if we can get there. All right. Good morning, Josh. Looking good. I'm broadcasting, double broadcasting right now, but the video isn't set up quite right yet. So let me set that up for us. And while I'm doing that, if everyone could join on Eclipse, that would be great. Okay, we should be broadcasting up there right now, and we should be going into Inception. We should be broadcasting up there right now, and we should be broadcasting up there right now, and we should be broadcasting up there right now. And okay, can someone please confirm that they can hear me in game, even though I'm double broadcasting at the moment?
Yes, we can hear you.
Great, thank you. And I'm going to slow down the music. And can someone confirm that YouTube is working for you? Great. All right, I'm going to, just before I switch gears, make sure you log into Eclipse for a sec, and we are going to, I'm going to single broadcast now as we go. Okay, switching over to YouTube. All right. Good morning, everyone. Today is Monday, February 15th. We're on class 15. We had our exam Friday. I had hoped to have it graded by today, but had some pretty, let's see. A friend of my daughter is going into surgery for an attack that happened this weekend. She was stabbed. And so she's going to be in surgery in like 45 minutes at UCLA Trauma Center. So that is on my mind a little bit. So that's kind of what's in the back of my head in addition to everything else going on. So I'm just going to open briefly with prayer for us and our class, as well as that particular burden that's on my mind, recognizing also that you all probably have similar things, hopefully not as dramatic, but certainly important in your world. So let's just take a second to arrive here. Dear Heavenly Father, we're reminded that, we really live in a world that's really corrupted by sin, and that is fallen. The echoes of our actions reverberate for long periods of time. And Father, we just pray for those of us who are in our community who are suffering from all kinds of stuff, Father. In particular for my daughter's friend who's in surgery, Father. We pray that you would be with the surgeons and her body and help it to heal. Pray for all of our mental health, whatever causes people to do this, and whatever additional burdens we're under given the current pandemic and politics and whatever our personal lives are bringing to the table. Father, we pray that we would be agents of restoration, that these things would inspire us to make the world a better place. Pray that we would be present for our community and our friends when they are in need, and if we are in need, that we will have those people for us. Amen. Okay. Yeah, that's rough. Okay. So what I want to do is I want to start off by a little example in Eclipse wrapping up our decision making. And so what I'm going to do is I'm going to present some slides here. Let me throw them up in a slideshow. It's just a one slideshow example, and now let me throw them onto the screen. Give me a sec to do that. Oh, good, that worked really well. All right, so here's the example of the little task that I want us to start with. So the scenario that we're looking at here is that you are programming a self-driving car, kind of an Uber of the future, perhaps. And what your car does is it is going to report back to the monitoring system, the system that's keeping track of where all the cars are, because the monitoring system needs to allocate cars to people who need rides. And your job is to return where the car currently is. The car can be at 1, 2, 3, 5 different locations. Each of them are parks. They're circled in green here on this slide. You're starting at Westmont, and your car is driving. And your car is recording where it's turning at 4 different intersections. So at intersection A, intersection B, intersection D. Each of those intersections, your car has either gone right or left. And your car is an object, and it has recorded the results of those turns. Some of them may not matter, right? So for example, if you have turned left at A, whether you've turned right or left at B, C, or D doesn't really matter because it's taken care of by the fact that you've turned left at A and you have a destination. So what I want you to do is I want you to fill out a class here in a moment that answers the question of where your robot car is. So let me switch over to Eclipse for a second. I'll put the slide back up in a moment, but let me switch to Eclipse so that we can look at what we're doing, not my calendar. Here's Eclipse. All right. And I'm going to start a session for code for today. And let me get that going. And if you, please don't edit anything yet. You need to go through the rigmarole of sharing code with everyone first. All right, those invitations are coming out right now. Go into Zoom. Not quite, I need to pass that. All right, and it's a small project, so it should share pretty quickly, even if you are not on campus. And so it looks like some of you have got it, and I'm going to go through and set read-only in place. Oh, let me let a few others of these synchronize. While they're synchronizing, let me walk you through the code. So currently there are two different classes. There's a class called robot car, and if we look at robot car, we can see that it is public. It has 4 instance variables right at A, B, C, and D. Those are the instance variables that we're keeping track of our turns with. And you can see that when we call our constructor, we build our object from the very beginning with a record of where it has turned at A, B, C, or D. That's part of how we construct our car. And all we do with that information is we store it in the instance variable, and then we immediately return. We don't make the decision at the point at which we are constructing our car. We're going to make our decision later. Whoever's using our robot car is going to create one of those objects. It's going to pass in the variables, and then in a separate method call can figure out where that car is. So right here, if the user of our class calls getLocation, then what the class is going to return is the string lost. But what I would like it to do is I would like it to return one of the strings associated with these different parks. So I would like it to return Hale Park or Parma Park, Franceschi Park, Alameda Park, or Chase Palm Park instead. It doesn't do that now, it just returns lost. And so your task is to fill in the code here. I'll put a little mark here. the way that we're going to call this is over in Robot Car app. We're going to make an API programmer, act like an API programmer, where we're going to do the work of instantiating our car and then calling it. So here you can see an example of instantiating the car class. We're instantiating it with true at each of those locations, so we've gone right at each of them. And what we want is we want the results of our car method. We want to return where we are. So we'll call car and then the get location method. And what we want to do is to print out where it actually is. If we run this right now, what we will see is that the car outputs, let's see, I've got an Eclipse bug in there. Once I save it, it should be okay. All right, what we've got is it says that the car is lost. So what I would like you to do is not edit this project. I would like you to create a parallel project that's not being shared, and I would perhaps call it class 15 underscore 02 underscore 15 underscore working. So that's where you're going to do your work. I'd like you to copy these classes into that project and then try and fill it out. And I'll give you a few minutes to do that. And you can do that while I'm trying to work with the rest of the folks to get our project shared. So what I'm doing now is I'm going through and I'm causing each of these to be read-only. Please don't move the classes as I'm doing that. Just you can copy them and paste them into your own project. And as I get down to the end of this, I'll re-invite those of you for whom the sharing didn't work the first time. All right. Even if you have shared, though, you are welcome to go ahead and copy those into a separate class, and then we'll work through it. Let's see. And so I guess you don't know who you are. Okay, so I'm making Sam read only, and I'm making Thomas read only, and that successfully makes everyone who shared the project on the first pass read only. Now I'm going to go through and reshare again with those of you who weren't online or for whom sharing didn't work. So first I'm going to reshare with Trent, and then I'm going to reshare with Morgan, and then I'm going to reshare or share for the first time with Dee Dee and Matthew and Landon and Faith and Ben A. Okay, as those are synchronizing, I'm going to go back through and I'm going to edit them in a moment to make them read only. I'm looking in game because I hear typing and I see maybe you're typing to each other. I don't see any messages in game. Shrink that up. Yeah, Matthew and Josh, I'll reshare in a moment. All right, I'm going to go through and I am going to, once Dee Dee is done sharing, all right, I'm going to go through and I'm going to switch Landon to read only. And I'm going to switch Morgan to read only. And I'm going to switch Dee Dee to read only. Hopefully that'll work okay. Okay, this seems all right. I'm going to try and reshare with Faith and reshare with Matthew and reshare with Trent. And Josh, I don't see you connected. You don't seem to be connected to OpenFire. Okay, my connection to, let's see what the comments are. Great. So Josh, Ben D, I don't see you connected to OpenFire. Faith, it looks like you're getting there. No, Faith, Faith, you might want to restart as well. Something's not going well with that connection. All right, we'll do one more pass, and then I'm going to work through a JUnit test, and those of you who aren't able to connect can watch that instead. Okay, let's try Ben D. Here you go. Faith, here you go. Try again. And then Trent. Faith didn't work again. We'll try Trent again. Oops. Trent dropped out. Faith dropped out. All right. All right, I'll try one more pass and then we'll move on to a JUnit test for this. Just letting those, whatever synchronization is going on, letting that happen. Okay, so we're all synchronized. Ben, switching you to read only. Okay, that seems to have worked. Trent, switching you to read only. That seems to have worked. All right, there, Josh, let's share with you. There you go. Faith, let me retry with you. And Matthew, let me retry with you. And we'll do, this will be our last one, and then we'll move on. Yeah, Josh, it failed on my end, or at least indicated a failure on my end. I'm not sure what's up with that. Okay, so those last ones try and connect. What I want to do now is I want to do something which is called test-driven development. And what we do in test-driven development is we create tests that are consistent with what we know we want our results to be. Yeah, those last three are failing. I'm not sure what's going on with you folks. We'll share the code with you afterwards. So on screen, what I'm going to do is I'm going to create a JUnit test. Let me switch over to a big, a slightly bigger screen so you can see how I'm doing that. Over on the right, I'm going to select the robot car class. I'm going to do right click and I'm going to say new JUnit test case. And it's going to ask me what class I'm testing. I'm going to choose the robot car, and then it's going to write it as robot car test. And I'm just going to check get location because that's the one that I want to test. All right, let me put that up next to here. So if you're, I'll show you what robot car looks like. So if you are watching and unable to share, you can maybe cut and paste that, or you can copy it if you can see it well enough. All right, so what I'm going to do is I'm going to write some tests for our robot car class so that we know whether or not it's giving us the behavior that we want. All right, so to do that, I've got my JUnit test set up here, and you can either follow along what I'm doing with the testing, or you can write an answer to this. Either way, you can check the results of this afterwards if you'd like. I know that I need my robot car to be at one of these different locations in particular cases, and so I want to set up cases that exemplify that. So I'm going to create a robot car here in my JUnit test. My JUnit test, I act as if I'm an API programmer. So I'll call it car A, or I'll call it car Hale, because that's the car that should end up at Hale Park. And I want it to be a new robot car. And what I want to do is I want to make sure that what is happening here is I'm initializing it with the appropriate turns so that it ends up at Hale Park. And so my first turn at A, that's going to be right at A is going to be false because I went left. And then the rest of them I don't even care about because once I get there, the rest of them don't matter. So if this is the case, I haven't implemented it yet, And let's see, what did I do wrong here? I have one too many booleans. There we go. If this is the case, then I know that carhail.getLocation, we know that that better be equal to Hale Park. And so I'm going to write my test, which is to assert that the following things are equal. And I'm going to assert that what I expect is for it to return Hale Park, and what it's going to give me is whatever the method returns. And let me make sure I import that correctly. Assert equals, import that. There we go. All right, so now if my implementation is correct, then after having created that car on line 12, then I better get back Hale Park. That better be right. And if I do, then I have some confidence that it's working correctly. But I'm going to write tests for the other three as well. I'm going to create a new car. I'm going to instantiate it as Parma. And instead of going left at A, I'm going to go right at A. And then I'm going to go right at B. And that should take me to Parma Park regardless of what C and D are. So we want that to end up at Parma Park. If I get a location on that car, there we go, car Parma, then I better end up at Parma Park. So I'm going to do that with the other examples. Franceschi Park, and there's Franceschi Park, and there's the Franceschi location, and that's going to be if I go true, true, and then true. If I do 3 rights in a row. So that's, oh no, true, false, true, because I want to go left at B to get there. Okay. Then my robot car is going to try and get to Alameda Park. And so in order to get to Alameda Park, I've got to go right, left, left, and then right. So that better get me to Alameda Park. And then the last one is going to be Chase Palm Park. And for that to get there, I better go right, left, left. Let's see, right, left, left, right. Right, left, left. Oh no, right, left, left, left. Okay. All right, so if my implementation is correct, then all 3 of those should work correctly. So here's the question now. You should be able to take this class and put it in your project that you made in parallel, and you should be able to run it. And if your code works correctly, then it will pass your JUnit test here. And if you've made an error, then it will not pass the test, and you will know that you have an error in your construction. So let me try and share one more time with our 3 folks, see if anything is fixed with them. Go to Faith and Josh and Matthew. And then is there anyone who would like to, thinks they've written it and would like to try it out publicly, so on feed? Waiting for sharing. All right, looks like Matthew made it. Looks like Josh made it. Maybe. Yep, looks like, let's see if Faith made it. Yeah, great. Looks like everyone made it. Okay, super. Since I'm not overwhelmed with people volunteering to, I guess you're probably having a hard time figuring it out without seeing the slides. So what I'll do is I'll give you a few minutes. Let me see, I'll give you like 4 minutes with the slide on the screen now that the code is successfully shared to see if you can implement robot cars get location method. And if you get it correctly, then your robot car test class should pass. And if you are trying to get this to work, you might have to make sure that you have your JUnit 5 library installed. And so a reminder of how to do that is you right-click on your project, you go down to Properties, Once your properties window is selected, you select Java build path from the left of the column. That's going to reveal a bunch of tabs. On that tabs, you want to select a library. And then in that library, you want to highlight class path and then add a library, which is going to be your JUnit library. If you do that, then you should be able to run your JUnit test. All right. All right, I'm itching to write some code. I'm giving you about 1 more minute to try and implement this. On screen, we're showing you the different choices that can be made by your robot car at position A, B, C, or D. And these decisions are all linked together. This is an exercise in making sure we understand how to write if statements in Java. In particular, this one entails a sequence of if statements. And there are different ways that you can do it depending on how your logic works. But what is true is that each one of these Boolean variables, right at A, right at B, right at C, right at D, they interact. So the results of where you are depend on a sequence of comparisons, a linear sequence of comparisons of these different Boolean variables. Boolean variable with the lowercase b is one of our primitive types. It is a non-object oriented version of Boolean. So there's no methods associated with it. It's just a value. Okay, so what I'm going to do is since no one is jumping up and down to try and test theirs out, what I'm going to do is I'm going to write an implementation on screen. So now I'm broadcasting on YouTube. Looks like audio is going through okay. I'm going to go ahead and write an implementation of it. And the first thing I'm going to do, though, is make sure that my tests are broken, because my tests are working. Why would I bother? So I'm going to run coverage as a JUnit test on my test get location to see what happens. And I'm waiting to see over at the bottom left, slightly off screen. Let me see if I can rotate that in so you can see it. Down here at the bottom left, oh, you know what I'll do? Yeah, can I do that? That's still not very good on screen. All right, so let me go down. All right, so down here at the bottom left, what I've got is the results of my JUnit test. And when I look at this, I can see how my test did. And I see, okay, I did not pass. And here's an example of why I didn't pass. If I click on test get location, I look at the failure trace and I double click on the first element at the top of the failure trace. It has a little icon of a J and an exclamation mark. What pops up on my screen is the result of running that assert equals command. And you can see that the left-hand side, what I expected was Hale Park, but what I actually got was the string lost. That is associated with line 12 and 13 of the JUnit test. So I'm going to hit OK and say, oh, my test is failing. Let me go see what's happening. And of course, I haven't implemented anything. So I'm going to go ahead and work on this. So I'm going to put my test class behind. And good. And I want to go ahead and go to my robot car class, and I want to work on get location. So I know that I need to make a decision based on what my different instance variables are. And if I look at this slide, I know that my first one is A. It's underneath my image there, unfortunately. But I know that if I have gone right at A, then I continue thinking about B, C, and D. So structurally, I think the way that I'm going to do this is I'm going to choose to have one particular string, which is going to be my answer. And that's going to be lost. And if I don't reset it, then what I'm going to end up returning is the string lost. So what I've done there is really not changed anything in the logic of my class. I've just refactored it so that I have this answer string. And that's because as I think about the way I'm going to do this, I'm going to have my answer string change over the course of my comparisons. And the first thing I know is I know that if, I'm going to write an if statement, if right at A is false, so I could do this, I could say if it equals false, then I want my answer to be reset to Hale Park. If it is anything other than false, then my answer is going to end up being lost. So let me save that, and I'm going to come down here on the left. Oh, you aren't seeing that. Okay. If you're following along in Eclipse, you can see that. Here's the code, and then what I'm going to do is I'm going to rerun my JUnit test down at the bottom and see how I do. Still fails. Let's see if we can figure out why it's failing. I don't like the way I'm having these multiple tests failing all at once, and I can't really identify which one it is. So I'm going to go back to my robot car test. I'm going to refactor my test, and I'm going to call my first test location Hale. And then I'm going to refactor out a bunch of other tests, because what I want to see in my JUnit test is I want to see each one of my tests, and I want to see them pass or fail as appropriate. So the first one's going to be Hale. The second one I'll call Parma. All I can think of is Parmesan cheese. Next one will be Franceschi. Can't spell that. Next one's going to be Alameda. And you can see that each time I do this, Eclipse is trying to tell me that I have two methods with the same name before I've had a chance to actually edit it. So Eclipse is faster than me. It's like John Henry and the steam engine. And the last one is going to be Chase, Palm Park. All right, I'm going to save that. And so now I've changed my JUnit test so that I've taken those tests, all 5 of those tests that were in one method, and now they're each in their own method. And I did that because when I run my JUnit test now over on the bottom left, I can now see which ones are passing and which ones are failing more clearly. Waiting for those results to show up. Why didn't my results show up? Let me try that again. I'm going to run my robot car test as a JUnit test. There we go. Now you can see on the left that there is 1 that passed, Hale, and 4 that failed, Alameda, Franceschi, Parma, and Chase. Not totally surprising, as what we've got going on here is a class that is only checking one location. Right at A is Hale Park. All right, well, if right at A is true, then we need to do some additional work. And because I don't want to run the next code, if I've already set an answer, I'm going to use the else statement here in order to capture everything else. So I know that if I've gotten to this point, then right at A must be true. And there are different ways I can structure this, but I'm going to structure it as a nested if statement. So here I've created an else block with some curly brackets. Sorry, it's hard to see because of the sharing. And I know that if I've gotten in this block, then my right at A is true. So I'm going to make another if statement within this block, and I'm going to say right at B. And if we have gone right at B, just take a look at that, we know that we are at Parma Park. So Parma Park is what happens if we're at right at B. So if right at B equals true, then my answer equals Parma Park. All right, so I'm doing test-driven development. So now I'm going to go back down and see how my tests are doing. So I'm going to rerun my Java JUnit test down at the bottom left. I've got 4 failures and 1 pass. Now I've got 3 failures and 2 passes because Parma Park's working okay. All right, we're getting there. That's pretty good. So now let's consider what the next one we want to do is. We're going to think about if we've gotten past A and B. So if we've gone left at B, then we're going to check to see if we've gone right at C. If we've got right at C, we're at Franceschi Park. So let's edit the code to reflect that. All right, so again, I'm going to put an else statement in here and a block that's going to nest it even deeper. And if right at B was false, then I'm going to check if right at C is true, in which case I'm going to set my answer equal to Franceschi Park. And hopefully I spelled that right. Franceschi Park. All right, I'm going to rerun my tests here, see if my tests do better. Waiting for a result. Franceschi Park did not work. So let's see what happened at Franceschi Park. So I'm highlighting test get location at Franceschi Park, and I'm selecting failure trace at the top. And I can see that what was expected was Franceschi Park, and what I returned was Franceschi Park. So what we have here is not a problem with my logic, but a problem with my test, because what I was expecting was something that was misspelled. So I'm going to go back to my test, where I'm expecting this complicated spelling of Franceschi, and I'm going to correct it so it's the correct spelling. It's correctly spelled like France. I'm looking carefully at my slide now. At France and then ski. France and then ski. Okay, I'm looking at my slides. My slides indicate that that is the correct spelling, France and then ski. All right. And so then if I rerun my test, let's make sure I did the right thing. Rerun my JUnit test. Great, we passed the Franceschi now. All right, so the next one to tackle, let's tackle Alameda and Chase Palm Park. Going back to robot car class. If right at C is not true, then we're going to do an else block, and we'll say if right at D equals true, then answer is going to be equal to something. I need to refer to my slides again to see what it's going to be. And since this is our last decision, if it's not true, then it'll be something else. Oh, actually, I remember now. Right at D will be Alameda Park. And if we go left, then we're at Chase Palm Park. All right, if everything is done correctly and I put semicolons instead of colons at the end, now I go back to running my JUnit test. Run those. Wait for the result. And we get an answer that all the tests pass. So that's great. That means we have really high confidence that our code is running correctly. Now, there are a bunch of choices that I made here in my code for how to structure this particular logic. A couple things I would recommend doing differently. For example, anytime you check to see if a Boolean equals true, you're putting extra code in there. There's no need to ask if true equals true. You can just, for example, here on line 36, you can just make that so if right at D, because that's either true or false, and so you can just make it if right at D. You don't have to say if right at D equals true, because right of D is true. And if it's true, then is true equals correct, is going to be correct. So all these ones where we check to see if it's true, then we can just remove the equals true and just check to see if the variable itself is true. Now in this case, when we're checking to see if it's false, we can't do that. We could do something else. We could say if the opposite is true, then it's okay. So we can do that. And then we can rerun our test to make sure that we didn't introduce any errors when we did that. Test still passed, so that's great. And then one other thing we could do is instead of putting these nested else blocks, we could chain them together. So let me just chain together the last one here. So on line 32, we ask if right at C. On line 35, we could restructure this and we could just say else if right at D, and then we can reduce our indentation a little bit and get rid of one of our semicolons. So in this case, we're doing a chained set of answers. So if right at C, then answer is this. Else, if right at D, then answer is this. Else, answer is this. So we were able to chain them together in that logic as well. Rerun the JUnit tests. Everything passes, so I didn't ruin anything. That's a regression test. I didn't introduce an error by refactoring my code. The last thing that some of you might have done is you might have done something like, rather than setting an answer string equal to the correct answer, you might have just, you could also instead just immediately return the correct answer. So you could also do something like this, where you immediately return the right answer, and then then you're never going to evaluate any other code because you're going to return immediately. So there are different ways of structuring this. All right, let me switch to in-game audio to see if there are any questions, and then we will move on to chapter 6. All right, I'm using in-game audio. I'm going out. Now you can hear me. Okay, so broadcasting again on YouTube, we're looking at loops now. And what we are interested in is working through that. We have a new chapter, and so it is only appropriate that with a new chapter, we get an update um, on Dodger. Let me find that. There we go. Our update on Dodger. Dodger had a good weekend. This is my wife collapsed on the floor after some sort of exhausting day in a dog pile with Dodger. She was actually trying to make me jealous that Dodger was hanging out with her, and that was successful. I was, in fact, jealous of the dog pile. The other thing is, you may or may not know my son. My son Theo goes to Westmont. He comes home sometimes to do laundry, and Dodger's always very excited to see him come home because he's part of our pack. And so this is Theo coming home to do his laundry and eat and eat. And Dodger is saying hello and is admiring Theo's mask. So that's our Dodger report. Dodger is in good shape. He has some new food from Trader Joe's, some new Trader Joe's dog food, also kibble. Okay, there's my calendar. So let's, wow, where'd my slides go? Where did my slides go? There they are. All right. All right, so we're going to talk about loops in chapter 6. We've seen a lot of different variations on loops, and I want to make sure that we're able to do it, but I don't want to belabor the point. So there's a handful of different kinds of loops that we're going to use. There's the while loop and the for loop and the do loop. And so to introduce these, I am going to go ahead and write some code to show you how they work. And then what we will do is we will walk through the slide deck to review them. So switching over to code and breaking out a new class that we can evaluate our code in. I'm going to create a new class in the existing shared project. I'm going to call it loops. I'm going to create a main for it because we're just going to run some example code. Bring it up. Can someone confirm that it's sharing okay? Okay, thank you. All right, and I'm just going to run a hello world to make sure that everything is operating all right. So far, so good. All right, hello world passed, looking down at the console. All right, so there are 3 kinds of loops that we're going to introduce in this chapter. The first one is a while loop. The second one is a for loop. And the third one is a do while loop. Yeah. 3 structures, 3 different use cases. You can use them in different ways. There's not like one is better than the other. It's just that you use them in different cases depending on the kind of logic that you want to implement and what seems most natural to you. So let's have each loop add up 10 numbers. That seems like an okay thing to do. So to do that, I'm going to need a kind of variable to keep track of a sum. So I'm going to start with a sum equal to 0. So I'm introducing a primitive type variable called sum, initializing it to 0. And then I'm also going to introduce an index variable. And index, I'll just call it I for short, and that's going to start as I. And I'm going to run a while loop, and I'm going to add up the first 10 numbers. And I'm going to say, therefore, while I is less than 10. So this is a condition, and it's a condition that is like an if statement in that every time we check this condition, if it is true, then we're going to run the code that's in here. And we're going to increment sum by whatever I currently is. When we get to the end of a while loop, it is almost exactly the same as an if statement, actually. The only difference is that when you get down to the bottom, line 13, what a while loop does different is it returns to line 11 and runs the conditional again. It'll evaluate whether I is less than or equal to true. And just like an if statement, just like as if this was an if statement, if it is true, then it will do the body of the while loop. And if it is not true, it'll jump to the end. The way this is not like an if statement is you can't do anything like an else. You can't put an else statement on a while. That's not part of the syntax, doesn't make sense. Eclipse will give you a complaint. So really it's just like an if statement with no else that you run over and over again. And so we can print the output of this at the end. And what we expect is we expect it to be, let's see, it's going to be the numbers. This is going to iterate through, it's going to go 0 to 9. And so we expect the answer to be, what do we expect the answer to be? We expect the answer to be 9 plus 8 plus 7 all the way down to the bottom. So we've got 1, 2, 3, 4, 5, 7, 8, 9. I'm looking at my fingers. So we have an odd in the middle, 1, 2, 0, 1, so 1, 2, 3, 4, 5, so 5 in the middle. So we have 9 and 1, 10 times 4, 45, I think. That's offhand what I'm expecting. And then what we'll do is we'll say at the actual is what we got for sum. All right, let's describe what's happening here in this string. So I have a string literal where I figured out what I expect it to be. This is like a light JUnit test. And then my actual value is the end of the string literal, and I'm adding sum to that string. So this is one thing that Java allows. Java allows primitive types to be upgraded into strings. So Java knows how to take a primitive integer and convert it into a string and attach it to the end of the existing string. So this is going to work like a string concatenation. Another way that I could do this is I think it'll let me typecast it as a string. No, it won't let me typecast it as a string. Okay, forget it. Can't typecast it as a string. Another thing I could do instead is I could do a formatted print, for example, and then rather than concatenating the string literal, I'm going to insert it as a second parameter here. Maybe that's a little bit cleaner, I think, so I'll do that. All right, so that's an example of our while loop, and let me just comment out everything else for the time being. All right, good. Let's run that, see how we do. I'm looking down at the console for a result. I don't see a result. Looks like the program's still running because there is a red square there. What has gone wrong? Why didn't my program end? I'm adding up numbers. I have a conditional that says I is less than 10. What's going on? Anyone want to throw something in chat and describe what's happening? Or yeah. Perfect. Thank you. So let's go ahead and add that. After we add I, we're going to increment I using the plus plus notation. That's equivalent to I equals I plus 1. Now we have to be careful about where we do our increment, because if we increment here, then the first time we add something to sum, I is going to be equal to 1. And in that case, we would be adding the numbers 1 through 10. But if we increment after we add, our first number is going to be 0, and then we're going to be adding the numbers 0 through 9. So when I did my back of the envelope without an envelope on my fingers calculation to expect 45, I was expecting adding the numbers 0 through 9. So we'll try that. Let's stop the existing code from running by clicking my red square right here, which is going to terminate the existing program. and then I will try and run it again. Great. That time it ran cleanly, it ended. My expected number was 45, my actual number was 45. So that's a basic example of a while loop, like an if statement that gets repeated. All right, now let's introduce the idea of a for loop. For loop is our second kind of loop. Oops. And I'm going to uncomment that if all goes well. There we go. Now a for loop is like a while loop, but we've got three different components here. Three different components separated by two semicolons. And what this is these are three different lines of code that are going to get run at very specific times. So the first line of code gets run before we enter into the loop. And so for that, I want to do the following. I want to say sum equals 0 because I want to reset my sum. I'm going to put a comma here, and I'm going to say I equals 0 as well. All right, and what this is doing is this is running, I don't know if that's too complicated. Maybe that's too complicated. Let's just keep it simple. Before we go into the loop, I'm going to say sum equals 0. And then when I start my loop, I'm going to say I equals 0. So this line of code right here, this I equals 0, it would be completely equivalent to doing this and putting nothing here. It's optional. We don't have to put anything there. But this space right here is for code that we want to run one time before our loop kicks off. So this is really good for initializing indices or different things that we want to do in the body of the loop. We can also declare things in here. So we could say, for example, let's make a new integer called j and initialize that to 0. And j will have a scope within the body of the loop only. It won't be known here once we're out of the loop. So we'll do that. We can keep that in there. Now here's the condition that we care about. So we care about, this is like our while condition, while j is less than 10. So this has to be a Boolean. It doesn't have to be in parentheses, but I'll put it in parentheses. And this is going to be acting just like our while condition. While j is less than 10, we will keep running the body of our loop. And then as a convenience, at the end here, we have something that is going to be run at the very end of our loop. And it'll be run every time at the end of our loop. So instead of doing j++ here, we can do j++ here instead. And so what we see here is that with our for loop, and then in here we'll do sum equals sum plus j. All right, now I've structured this in a very specific way. I've structured this in a way that I want you to be able to see the comparison between the code above and the code below because it's doing the same thing. Let me see if I can clean this up a little bit so that the comments are a little bit distracting here. So let me clean up the comments so we can see the comparisons. All right, that's helpful. All right, see, both of these loops are doing exactly the same thing, but what you can see is the way in which the for loop helps to organize common patterns in the while loop. So in line 9, a common pattern is that we initialize some variables before we go into our loop. That happens on 7 and 8. And instead of doing that outside of a while loop, we'll do that in our for loop right here. The other thing is we have a conditional. That's in the middle, so that's exactly the same, but we've replaced I with j. And then the other common pattern is we do something at the end to update our index variable. And instead of putting I++ here, we do j++ here at the end. And then the body of our loop, the thing that's doing the work, is exactly the same right there. Let's put our expected out here. Everything's okay. One other thing to notice is that I didn't redefine my sum variable. What I didn't do is I didn't say, oh, int sum. I didn't create a new variable because I've already got a variable called sum that I've declared as an integer. All I needed to do was to reinitialize it or to set it equal to 0. So now if I run this, I have an error because what did I do wrong? Maybe I didn't have a final semicolon down there. Yeah, I commented out the final curly bracket on line 20. Let me save that so you can see the code. Let's try and rerun that. Great. Expected 45, actual 45, that was the first one. So let me preface that and say that's the while loop. And now we've got a for loop. And we can rerun that to just make sure that we see what we think we're seeing. Great, everything's good. All right, the last kind of loop we can do is a do loop, and a do loop is really a variation on the while loop. The only thing that's different is that a while loop operates because by checking the condition before you enter the loop, and a do loop works by checking the condition at the end of the loop. So the difference between a while loop and a do loop is that the do loop is always going to run the body at least one time. A while loop may not run the body at all. A while loop may not run the body at all because the conditional check comes first. A do loop will run the body at least one time because the conditional check comes at the end. All right, so let's set this up so that we get the same behavior. So sum equals 0, and we don't have any natural way of there's nothing in the language that supports an initialization here, so we're going to have to manually initialize. Let's create a new variable k to keep it in parallel with the other two examples. K equals 0. In the body, we're going to say sum equals sum plus k. Let's use a shorthand for this instead. We'll say sum plus equals k. That's going to do the same thing. That's equivalent to saying sum equals sum plus k, kind of something you learn from muscle memory over time. In this case, we need to actually update our variables ourselves. So we'll say k plus plus, and we'll say while k is less than 10, that's not actually going to give us what we want. If we want to sum 0 through 9, we need to make sure, is that going to work? Let's see, 0. What I'm doing is I'm thinking through the logic about the ending condition, because the last time I want this to pass through the loop is I want 24 to do sum equals sum plus 9. So 9, then we'll increment it, and then it will no longer be less than 10. Yeah, so that's good. All right, so let's put a check at the end, change to do loop, and then we'll run this. And as a result, we get what we expect. So those are the three basic kinds of loops. I'm going to switch over to our slide deck here, and let me see if there are any questions about the basic structure, and you can look at that in Saros through the code sharing while we walk through the slides on that. If I can find the slides again. There we go. Double broadcasting for a sec. Okay, broadcasting in YouTube. All right, so our while loop, basic loop, a loop in general is what computers are best at. They are, you cannot see my slides. Let's see. There's a full slide. Okay. Loops generally are good at repeating code over and over again. With slight variations on each pass through the loop, those slight variations are controlled by variables that change each time you go through the loop. Maybe the index, maybe an accumulator like sum. Maybe each time you go through the loop, you might ask for input from the user. Maybe each time you go through the loop, you'll ask for data from a database. You'll make a network call, something that's repeated over and over again. This kind of behavior, this repetition at large scale, is exactly what computers excel at. So that's what we're doing with our loops from a big picture perspective. Possibly for calculations, possibly for input, all kinds of different things, possibly for output, all kinds of different things you might do. Basically, anything where we process lots of data items. An example of this might be an investment problem. We would like to be able to calculate the result of an investment. For example, if we put $10,000 into a bank account and we would like that, stand by, let me see if I can slide this. And we would like that bank account balance to be known. We would like to know how much it is, and we'd like to know how many years it would take for the account balance to double the original investment. There are different ways in which you can structure such a question with loops. Send Eclipse away for a sec. Um, I don't know if you noticed when I was doing the loop work in my head there. Um, sorry, I'm monkeying around. I was doing this kind of hand tracing in my head as I was trying to identify whether the variable k was going to end up going through the correct values of 0 through 9, and whether when I reached the conditional at the end of my do loop, I was going to be evaluating k at the correct time with respect to when it was getting incremented. I was doing that in my head because I'm familiar with the process and I've done it a lot of times. When you first start on this kind of work, you often have to do this by writing it down on a piece of paper. And this kind of or paper, or whatever you're writing it down on, something where you're able to jot down the logic, because sometimes it's hard to keep it in your head when you're not familiar with how these things execute. So in the case of this loop where we're trying to calculate the interest on a bank account, it's a good example of that. Maybe it makes sense to write pseudocode first, like what is shown here in red, where we start with a year value of 0, and we write down a row for every pass through our loop. Stand by, getting updates from my school, kids at school. First pass we'll say is year 0, and that corresponds to some variable that we're going to keep track of called year, and some variable called interest, and some variable called balance. We're going to start going into our loop with year being initialized to 0 and balance being initialized to 10,000. And we know that by the requirements of our problem, we're going to keep track of how year grows until we leave our loop. And the reason we leave our loop is going to be because our initial investment has doubled. So that's going to be our condition when we leave our loop. And what we're looking for is we're looking to see what the value of year is when we have left our loop, because we don't know how many years it's going to take to double our balance. So we'll think about the pseudocode for this. So we're going to repeat the following steps as long as our balance is less than 20,000, which is the double that we're looking for. Every time we go through our loop, we'll add 1 to the number of years that we've simulated. And to simulate that 1 year of money in the bank, we're going to calculate how much interest we earned, and we're going to assume a 5% interest rate. Of course, for bank interest right now, that's crazy. Bank interest is like 0.01 or something. But you can get a 5% interest rate from a bond fund if you want to think about it in terms of investing. Or you can get, 50% interest from, say, a GameStop fund if you're feeling particularly high risk. Compute that interest for every year. That's an amount of money. It's 5% of what your balance was. And then you're going to add that. And so at the end of the first year, your balance is going to be what you entered the year with plus the interest, and your balance is going to be slightly higher. Now, the whole scenario, the whole logic of saving money with an interest rate is that every year the amount of interest you get goes up because the balance that you're calculating your interest on also goes up. So the second year, we go into the year with a balance of 10,000 plus 5% of 10,000. And so the second year, when we're complete, we're going to end up with money which is 10,000 plus 5% of 10,000 plus 5% of 10,000 plus 5% of 10,000. So we're going to keep adding 5% until finally our balance is over 20,000. Then we'll report what our answer is at the end. So to do this, we'll use a while loop. Wait, why did I? Oh, sorry. This is just a slide I put in here to introduce the general idea of a while loop. And if it helps, you can think about a while loop as being like a particle accelerator, where a particle goes around and around and around the structure. This is an aerial view of a particle accelerator in the snapshot here. A particle is something like an electron or I guess mostly it's electrons. At some point, when the electron has enough energy, it is redirected out of the loop to slam into like gold foil or something and detect the X-ray scattering that happens trying to identify particles. So that process of going around and around and around until you reach some energy level is like a while loop. All right, so in the case of our while loop, we want to continue our loop while our balance is less than 20,000. So we're going to use the while loop condition that we've seen here. Just like the if statement, you can have a one-line while loop. Let me just confirm that because actually I haven't done that in a long time. It's rare that you'd ever do that. Let's see if we can do that. So yeah, a while loop, you're allowed to do a one-line while loop without curly brackets, but of course that's going to have a bug because of what we saw before. That is a one-line while loop, but it never increments I, so you'll be in that one-line while loop forever. All right, just double checking that. Typically, you'll have your curly brackets to indicate your arrangement, and as long as your condition's true, you'll evaluate your while loop. In our case, this is how we would like to implement our code. We would like to say while our balance is less than our target balance is going to be 20,000, we're going to simulate a year. And as we simulate our year, we're going to increment our year variable by 1. And we're going to have our interest be equal to whatever our balance was at the current moment, not our first balance, but our accumulated balance, times our interest rate. And then we're going to increment our balance by our balance plus our interest. And we'll continue doing this until as our balance grows, our conditional goes up and up and up. All right, we'll pick up with this example on Wednesday, and I would like to also get to some simulation examples on that use a little bit more sophisticated version of while loops and random numbers. So with that said, let me check in a second from, let's see, I'm going to broadcast in game. For a sec. You're welcome. Thank you for your attention. See you on Wednesday. Okay, class is over. This has been class for February 15th, Monday, February 15th. Let's go back to holding zone. Actually, let me I think maybe I'll go to my next class so that when class starts, we will be ready to go. All right, that's it. Ciao. See you later.